now on to 2.3. So in 2.2 we talked about multiplication. We multiplied two binomials together, right? And then we even got to multiplying a binomial and a trinomial, okay? But today we're going to continue with multiplying, talking about special products. Special products. Products is multiplication. Special products of polynomials. So we want to look for patterns, and we can save time, honestly, if we can identify some patterns. Okay, so let's look at what we have here. We have this question of what are patterns in the special products of these right here. So if we take these first two binomials right here, now we're not using any specific values. We're just using a and b, and we're just using a and b to represent terms, or to represent the monomials. Okay, represent monomials. So let's say that we have here a plus b, a minus b. So basically what we're saying is that these are the same terms, and then these are the same terms. The only difference between these binomials pretty much is the operation that happens between them. So this one's minus and this one's positive. Okay, so let's multiply these out using methods that we learned before. I'm going to use the FOIL method. So the first terms, which is a and a, so that's going to be a squared. The outer terms, which is a and negative b, so it's going to be minus ab. And then the inner terms, which is b times a, so plus b and a, b times a. And the outer terms, which is negative b squared. Okay, so we have four terms. Now we can simplify this because these are the same, right? These ab is the same thing as b times a, okay, because they're commutative. This is multiplication is commutative, right? For this in this context, so these can be swapped. Multiplication can be swapped because 3 times 2 is the same thing as 2 times 3, right? If I want to use a specific example. So those are the same. So I'm going to say that this is equal to a squared. But if you subtract and add them together, then those actually go away. So then we're just left with a squared minus b squared. Okay? So that's one pattern that we see here. So whenever you have the terms inside are the same, but the only thing different is one is plus and one is minus, you can see that the inner terms right there will be gone because you're adding and subtracting them, right? So then we're just going to be left with our outer terms, which are both squared, a squared and b. A will be squared and b will be squared, and they'll be subtracted. Okay, let's look at the next special product, which is a plus b squared. Now this is equivalent to a plus b times by a plus b, right? Because we're saying we're multiplying this term by itself twice, right? Okay, so if we do the FOIL method, we're going to have a squared for the first terms. For the outer terms, we're going to have plus ab. For the inner term, we're going to have plus ba for the inner term. And then for the last terms, we're going to have plus b squared. So we can simplify this again. So these terms are the same. These are like terms. We can combine them. So this is equal to a squared plus 2ab, because we have two of them, 1 and 2, and we're adding them. And then plus b squared. Okay? Alright. So whenever we multiply two polynomials that are the same, two binomials that are the same, and the operation inside them is the same, then we can notice that this is going to be this is what it's going to look like. Okay. Now for the last special product that we have a minus b squared. So a minus b squared. So that's equal to a minus b and multiplied by a minus b, so it's multiplied by itself twice. Okay, using the FOIL method, we get a squared when we multiply the first terms. For the outer terms, it's minus ab. For the inner terms, it's minus ba. And for the last terms, it's plus b squared, because negative times a negative is positive. Okay? We can combine the inner terms again, so this is equal to a squared, but we're subtracting them twice, so that's minus 2ab plus b squared. Alright? So you see here, that's identical. These two are identical, except for this operation that's happening here. Okay? So these are special products. Okay? So if we come down here and we use this, what we have up here, let's think of these right here. Okay? So right here, we have two of the same polynomials, except for the fact that this is plus and this is minus. So that's similar to what we had in this first example right here. So we had a squared minus b squared. So in our example here, a is equal to x, and b is equal to 3. So if we know this, then we can just plug these into our what we just found up here, the pattern that we saw. So if a is equal to x, then this is going to be x squared minus 3 squared, because b is equal to 3, which is a squared minus 9. Okay, so we just used a shortcut, right? Because we already know from up here what it should look like. Okay, now for b, it's the same thing. We notice here that these are similar polynomials, just that the operation inside is different. Okay, so we know that it should look like a squared minus b squared. Okay, so when that happens, we know a in our particular, in this specific example, is equal to x, and b is equal to 4. So then if we use our equation up here, we get x squared minus 4 squared, x squared minus 16. Alright, now let's come over here. So same thing, a squared minus b squared, where a is equal to 3x, b is equal to positive 1, just 1. Just include this, don't include the sign. So if we put that into this right here, we get 3x squared. Okay, like that. Make sure you include your parentheses, minus b squared. Now 3x squared means that we're going to square the 3 and the x, so that's going to be 9x squared minus 1. Okay? So with their specific names for each of these three examples. Okay? So the one down here that we've been practicing, where you have a and b, similar terms right here, but just a different operation inside, where this is plus and this is minus right here. This is called the difference, sum and difference. Okay, so sum and difference, and here's the example over here. Okay, and then up here we have square binomial pattern, where if it's plus, then this is what it's going to be. If it's minus, then this is what it should look like. Okay, and just some examples over here. Okay, so if you ever see something like that looks like this, or like this, or like this, okay, then you can just go ahead, use substitution, and use these right here to just skip to the answer, instead of, distributing or using the table method, or using FOIL method, or stuff like that. Okay, so let's go over some examples here. So a plus 3 squared. Okay, so if we go up here, we have an example where the inside operation, the operation inside the binomial is addition, and it's being squared. Okay, so that's going to be a squared plus 2ab plus b squared. So we know it should look like a squared plus 2ab plus b squared. So we just have to make our substitutions. Okay, so a is equal to a, that's the term right there. This time b is going to equal 3. So just make your substitutions. So that's still going to be a squared plus 2. A is a, but this time b is equal to 3. Okay? Plus 3 squared. So this is a squared plus, see, this is all being multiplied. This is 2 times a times 3, right? So it's commutative, so I can multiply these together. So it's going to be 6 times a. Alright, and then 3 squared is 9. So there you go. We have a squared plus 6a plus 9. Now over here, our inside operation is subtraction, which was this right here. So this is going to be a squared minus 2ab plus b squared, where a is actually equal to b, it's just that first term. Okay, b is equal to 2. So all you have to do is sub those in. So instead of a, it's going to be b squared minus 2. A is b, and b is going to be 2, plus 2 squared. So b squared minus, I can multiply these together because by the commutative property, so that's going to be minus 4b plus, and then 2 squared is going to be 4. Alright, now c plus 4 squared. So in this case, this is plus, so we're going to have, this should look like a squared plus 2ab plus b squared, where a is equal to c and b is equal to 4. So then we're going to have c squared plus 2c times by 4 plus 4 squared. So c squared plus 8c plus 16. Okay, so go ahead and try 4, 5, and 6. I'll go ahead and do one of these ones down here. So maybe do 16. Okay, so let's do 16. So right here we have a plus and a minus, right? Plus and a minus with similar terms on the for a and b. So this should be a squared minus b squared. That's what it's going to look like. So a is going to look like negative m. B should be 2n. Okay, so for a squared, this is now going to be negative m squared minus, and b, which is 2n squared. So negative m squared will be m squared minus 2n squared will be 4n squared. Okay. Now you could always just use your other properties or other methods and multiply this out if you want to double check it. So if I use the FOIL method, those two multiplied together is m squared times by positive 2mn. Okay. Multiply those together, that's going to be negative 2mn, and then these two, which will be negative 4n squared. Now these will cancel out and we get the same thing, right? Okay. So that would be the answer. Now I'll let you try 17. Let's try number 6 because this one looks scary with the fractions. So I'll try and help you on this one, okay? So these are similar right here, but you see that these are both positive. So this is the same thing as 6a plus 1 over 2b squared. Okay? So that means we should look like a squared plus 2ab plus b squared, where a is equal to 6a, this term right here, and b is equal to 1 over 2 b. So let's plug that into this equation. Substitute. So 6a, we'll sub in for a, so it's 6a squared plus 2 times by a, which is 6a, times by b, which is 1 over 2 b. Okay? And then plus b squared, and b was 1 over 2 b squared. So let's simplify this. So 6a squared should be 36a squared times plus 2 times by, so we have 6a and 1/2 b. So 6 times by 1/2 would be 3, and then a times by b. And then for the last term, it's 1/2 b squared, which would be plus 1 over 4 b squared. And then we can still simplify this even further, because right here, this is all being multiplied right here. So this will be